The fuel system on the 777 is similar to other Boeing twin-engine jets in operation. The fuel system includes a center tank, 2 main tanks, and 2 surge tanks. A fuel cross-feed system connects the left and right fuel manifolds through 2 cross-feed valves. The left and right main tanks each contain 2 AC motor-driven fuel pumps. The center tank contains 2 AC motor-driven override jettison pumps. These pumps have a higher output pressure than the main tank pumps and are used for normal fuel feed as well as fuel jettisoning. A DC fuel pump located in the left main tank feeds fuel to the APU until AC power is established. Jettison pumps located in each main tank assist the center tank pumps in jettisoning fuel from all 3 tanks. Each fuel tank contains sensors that input their data to the fuel quantity indicating system. The fuel quantity indicating system uses fuel height and density to calculate fuel quantity in kilograms. The fuel quantity is displayed full-time on the lower right corner of the ICAS. The fuel temperature is also sensed and displayed full-time on the ICAS. The controls for the fuel system are located on the overhead panel. Notice that the panel layout resembles a simplified fuel schematic. To help us review the fuel system, select the fuel synoptic. The fuel synoptic is also a simplified schematic of the fuel system. Text and symbols represent the current status of the system components. Boxes represent the pumps, and green bars represent fuel flow. Some components, such as the APU and fuel jettison system, are only displayed when activated. Now let's operate the system. This is the fuel panel normal configuration during pre-flight. All fuel pump switches are in the off position. With the pump switches off, the low pressure lights of the left and right main tank pumps are illuminated. However, the center tank pump pressure lights are extinguished. These pressure lights are inhibited when the pump switches are off. When AC power is established and the APU is running, the left forward fuel pump operates automatically regardless of switch position. The pump pressure light is extinguished, indicating left forward fuel pump operation. When AC power has not been established and the APU is running, a DC fuel pump automatically supplies fuel to the APU. Fuel quantity for each tank is shown in kilograms. The total fuel capacity of the airplane is approximately 94,300 kilograms, depending on density. Total fuel on board is displayed at the top of the synoptic, as well as full-time on the ICAS. Prior to engine start, all fuel pumps must be turned on for tanks containing fuel. Push the left aft fuel pump switch on. The on indication now appears and the pressure light is extinguished, indicating that the pump is operating. Continue configuring the fuel panel by turning on the remaining fuel pumps for the left and right main tanks. These pumps are now operating and are capable of providing fuel under pressure to their respective fuel manifolds when the engines are started. With fuel in the center tank, turning on a main tank pump displays the Fuel in Center ICAS message. Also, the fuel quantity display on ICAS changes to an expanded format showing individual fuel tank quantity. Complete the fuel panel configuration by turning on the left and right center tank fuel pumps. The center tank pumps have a higher output pressure than the main tank pumps. As a result, notice that the left center pump overrides the left main tank pumps to feed fuel to the APU. The center tanks also override the other main pumps when the engines are started. The fuel panel is now configured for engine start. All tanks contain fuel, so all fuel pumps should be turned on. The cross-feed valves are controlled by these two switches. The switches should be off and the valves closed prior to engine start. The left and right fuel manifolds are isolated when valves are closed. The cross-feed system is only used in non-normal conditions and will be discussed in more detail later. When the engines are started, the spar and engine fuel valves open, feeding center tank fuel to the engines. Turning off the APU removes the APU symbol and fuel flow from the synoptic. Initially, fuel is burned from the center tank because of the higher output of its override pumps. When the usable fuel in the center tank is depleted, the ICAS advisory message, Fuel Low Center, appears. The associated pressure lights also illuminate. Turn off the center pump switches. Remember that the center tank pump pressure lights are inhibited with the switches in the off position. Scavenge pumps automatically transfer any residual center tank fuel into the main tanks. After engine shutdown, all fuel pumps should be turned off. Turn off all main tank fuel pumps. The system is now completely deactivated for your shutdown procedures. During flight, fuel can be jettisoned to reduce the gross weight of the airplane. The first step in jettisoning fuel is to arm the jettison system. Push the fuel jettison arm switch to arm the system. Notice that the armed indication and the jettison portion of the fuel synoptic appear. The fuel temperature on ICAS is replaced by fuel to remain. The fuel to remain initializes to a fuel quantity that will leave the airplane at maximum landing weight. This knob sets the fuel to remain value if other than maximum landing weight is desired. Let's increase the fuel to remain to 54,400 kilograms. First, pull the fuel to remain selector out. Notice that manual appears in amber, replacing maximum landing weight when the fuel to remain selector is pulled out. When rotating the fuel to remain selector left or right, the fuel to remain value changes slowly. Rotating the selector further left or right changes the value more quickly. Rotate the selector clockwise and hold until the fuel to remain reaches the desired value. When the fuel to remain value reaches 54,400 kilograms, release the selector back to center. The selector knob must be left pulled out. If pushed in, the fuel to remain value reverts back to the maximum landing weight fuel. The final step in jettisoning fuel is to activate the system by pushing both nozzle switches to open both nozzles. Push both fuel jettison nozzle switches on. Notice the on indication appears and the jettison isolation valves open. The main tank jettison pumps are activated and both jettison nozzle valves open. Fuel is now being jettisoned from all three tanks. The jettison time is displayed on the fuel synoptic in minutes. Standpipes ensure at least 5,200 kilograms of fuel remain in each main tank after fuel jettison is complete. All center tank fuel can be jettisoned. Jettisoning automatically terminates when the fuel to remain target is reached. The fuel to remain value flashes to alert the crew to fuel jettison completion. The main tank jettison pumps automatically shut off and the jettison isolation valves close. Although fuel jettisoning stops automatically when the fuel to remain value is reached, the crew must close the nozzles manually. Push both fuel jettison nozzle switches to close the nozzles. We pulled the fuel to remain selector out to manually set the fuel to remain target value. Push the selector back in now. Finally, push the arm switch to disarm the fuel jettison system. The fuel synoptic shows that jettisoning is complete. Fuel jettisoning can be manually terminated at any time by closing both nozzles or deselecting the arm switch.